Welcome back to the classroom. My name is Mr. Wong. Today we're going to be going through a question on circular motion. This is Module 5, Inquiry Question 2 of the HSC paper. This is the 2021 HSC Physics question, question 22. And obviously, as we talked about, it's about circular motion. We have a horizontal disk that rotates at a constant rate. What that actually tells us is the angular velocity is the same. We have 2 points on the disk, x and y, as labeled here. X has twice is twice as far away from the center as y is. So we could say the distance from the center of y is r, and the distance of x is 2r. Okay, so the question we have here, it says compare the angular velocity and the instantaneous velocity of x and y. Instantaneous meaning by the linear velocity, so the value of v. Let's go through some of the theory work here. So I know that omega is constant. Let's look at the relationship between angular velocity and linear velocity. So how can we put it? So the angular velocity is equal to v over r. Okay, so that's the actual formula to show their relationship. If omega is constant, let's say, omega is 1 because it's constant, v and r, if I move them around, I can actually show that velocity is directly proportional to the radius from the center. So what's the significance of that? Let's have a look at our diagram here. Let's say this is our center point. This is R, and then this is our R2. Okay? So, as we said here, the velocity would increase if the radius was to increase, and if the radius was to decrease, the velocity would also decrease, so to speak. So, what we have here, we know that x as a radius is twice as big as the radius of y, which means we should expect that the velocity of x should be also bigger than the velocity of y. But by how much? Well, if we've increased the radius by 2, then because the velocity, instantaneous velocity, and the radius is directly proportional, then the velocity would also increase by that amount. So overall, x has twice the linear velocity of y. That's how you explain it. So let's try and word it, let's say as a table, and we can go through that. So when we're trying to do a compare type of question, you could try and do it in subheadings, and you can explain like that. I'm going to show you a slightly different format, which is using a table. So I'm going to say this is x, this is y, and we're going to talk about its angular velocity and linear velocity. So the angular velocity is the same, and we know that x for its instantaneous velocity is twice as large as y and half the speed of x. That's my comparison there, but let's just make sure we give an explanation as to why that's the case. So I could say as angular velocity is constant, the instantaneous velocity is directly proportional to the radius. as the radius of x is 2 times as big as radius of y, x has twice the speed or instantaneous velocity of y. And that's how you solve this problem. If you found this explanation helpful, hit the like, subscribe, and I'll see you next time.